Welcome to EDU World Space.
So in this question, we have an electron, and we want to do two things about it. Part A, we want to accelerate that electron from a speed of 3.00 times 10 to the 6 meter per second to 8.00 times 10 to the 6 meters per second. And we want to know what is the potential difference required to accomplish this. And part B, we want to know what is the potential difference. So we'll bring it from 8.00 times 10 to the 6 meters per second to a stop. And to do this, we need to use the energy conservation. And we know that when electron is speed up or slow down, what is changing is the kinetic energy of it. And because due to the energy conservation, whatever changes of the kinetic energy, it has to be caused by the potential energy. So the potential energy and the kinetic energy will have to add up to be the same. So in other words, we know at 2 points, V1 plus K1 equals V2 plus K2. Or actually, I should write it's U1 plus the kinetic energy plus the potential energy at one point is equal to the potential energy plus kinetic energy at the second point. So we want to know the potential difference. So we want to know delta V equals V1 minus V2 equals U1 minus U2 over Q, because potential is potential energy divided by Q. And this is equal to Kq minus K1. Because of this, U1 minus U2 equals K2 minus K1 divided by Q. So now we can plug in all the numbers here. We have kinetic energy is 1/2 of mv squared, 1/2 me of v2 squared minus v1 squared over charge of electron. Now we put in some numbers. I'll move this down. We were putting some numbers. 1/2 of the mass of an electron is, you can look it up. I think it's 9 times 10 to the negative 31, I believe. Let me just double check. Okay, yes, it is 9 times 10 to the negative 31 kilogram, and times v squared. V used to be 8 times 10 to the 6 squared minus 3 times 10 to the 6 squared. And this whole thing divided by the charge of the electron is negative. It's negative 1.6 times 10 to the negative 19 coulomb. Okay, so this gives us a potential difference of negative 156 volts. So what it's saying is that the potential difference has to accomplish it. So the initial point, if it's traveling in this direction, the initial point is actually at a lower potential than the end point. And that is expected because it's a negative charge that's traveling. So it will move from negative potential to positive potential, as opposed to a positive charge would move in the opposite way. Okay, so in part 2, it asks what is the potential difference. So we bring it from this kinetic energy to 0. And we have the same formula, V1 minus V2 equals K2 minus K1 over Q. So this is, K2 is just 0. So we have 0 minus 1/2 of me. And K1 is 8 times 10 to the 6 meters per second. Here I all have meters per second, squared over negative 1.6 times 10 to the negative 19 coulomb. And this time it gives us a positive value. It gives us positive 182 volts. And again, that is to be expected because right now we're decelerating, and when a negative charge goes to the positive, goes from a higher potential to a lower potential, what it does is it will slow down is when it goes to a lower potential, because you can imagine it as if it's almost as if a negative charge is moving closer to a negative charge, so it will be repelled and it will be slowing down. So yeah, so that is the answer for the two questions. It's a negative value for part A and it's a positive value for part B.